Students, welcome to our V4U Chemistry channel. Here you can find the unsolved numericals of K.L. Kapoor Volume 1. Today's video content is numericals based on how to calculate pH of a salt of a weak base and salt of weak acid and weak base. In the above question, given concentration of ammonium chloride, C equal to 0.015 molar. Dissociation constant of ammonium chloride is 1.8 multiplied by 10 raised to power minus 5. Ammonium ion on hydrolysis gives ammonium hydroxide and hydrogen ion. Hydrolysis of ammonium ion is the combination of two reactions. First reaction is the reverse of dissociation of ammonium hydroxide and second reaction is the dissociation of water. Hydrolysis constant is equal to dissociation constant of water divided by dissociation constant of ammonium hydroxide. At equilibrium, ammonium ion concentration is C multiplied by 1 minus degree of hydrolysis, ammonium hydroxide is concentration of salt multiplied by degree of hydrolysis. Hydrogen ion is concentration of salt multiplied by degree of hydrolysis. Dissociation constant of hydrolysis is equal to CH squared divided by C multiplied by 1 minus degree of hydrolysis. Degree of hydrolysis is very negligible in comparison to 1. CH square equal to Kw divided by Kb. Degree of hydrolysis is equal to square root of Kw divided by C multiplied by Kb. Hydrogen ion concentration is equal to C into H. By putting the H value, hydrogen ion concentration is equal to square root of C multiplied by Kw divided by Kb. By doing log on both sides, pH is equal to half sum of 14 minus log C minus P Kb. pH is equal to 7 minus half sum of P Kb and log C. By putting the value of Kb in concentration of salt, pH equal to 5.54. Part B, if the solution is diluted 100 times. New concentration of diluted salt is C1 divided by 100. pH is equal to 7 minus half of P Kb plus log C minus 2. On solving pH is equal to 6.54. Answer Part A equal to 5.54. Part B pH equal to 6.54. In the above question, given aniline chloride is 0.04 molar. Dissociation constant of aniline is equal to 4 multiplied by 10 raised to power minus 10. pH is equal to 7 minus half of P Kb plus log C. By putting the value of Kb and concentration of salt, pH is equal to 7 minus half of minus log 4 plus 10 plus log 4 minus 2. On solving, pH is equal to 3.0. Answer pH equal to 3.0. In the above question, given concentration of ammonium acetate equal to 1.0 molar equal to C, concentration of sodium acetate is 1.0 molar. Dissociation constant of acid and base equal to 1.810 raised to power minus 5. Ammonium acetate is combination of salt of weak acid and weak base. In solution, ammonium acetate upon hydrolysis gives ammonium hydroxide and acetic acid. This reaction is a combination of reverse dissociation of ammonium hydroxide and acetic acid and dissociation of water. After combining three reactions, dissociation constant of hydrolysis is equal to dissociation constant of water divided by dissociation constant of acid and base. At equilibrium, concentration of ammonium and acetate ion is C multiplied by 1 minus degree of hydrolysis, H. Concentration of ammonium hydroxide and acetic acid is C multiplied by degree of hydrolysis. Dissociation constant of hydrolysis is equal to Kw divided by Ka and Kb. Dissociation constant of hydrolysis is also equal to H squared divided by square of 1 minus H. H divided by 1 minus H is equal to square root of Kw divided by Ka and Kb. Dissociation constant of hydrolysis is equal to multiplication of concentration of product divided by reactant, which is equal to ammonium hydroxide multiplied by acetic acid divided by ammonium ion and acetate ion. Dissociation constant of acetic acid is multiplication of acetate and hydrogen ion divided by acetic acid. On rearranging, hydrogen ion divided by Ka equal to acetic acid divided by acetate ion. By putting the value of ration of acetic acid divided by acetate ion in KH equation. KH is equal to ratio of concentration of ammonium hydroxide and hydrogen ion divided by ammonium ion into dissociation constant of acetic acid. Kw divided by Kb equal to square root of Kw divided by Ka and Kb multiply by hydrogen ion concentration. On rearranging, hydrogen ion concentration is equal to square root of Kw into Ka divided by Kb. By taking log on both sides, pH of salt of weak acid and weak base equal to 7 plus half of pKa minus pKb. Percent hydrolysis can be calculated using degree of hydrolysis multiply by 100. By putting the value of K west divided by square of Ka as Ka is equal to Kb. On solving, H value comes out to be 0.55 multiply by 10 raised to power minus 2. Percent hydrolysis of ammonium acetate is equal to 0.55%. In sodium acetate case, acetate ion on hydrolysis gives acetic acid and hydroxide ion. KH equal to Kw divided by Ka, which is also equal to CH square. H is equal to square root of Kw divided by Ka into C. By putting the value of Kw, Ka, C, we get H equal to 0.2354 multiply by 10 raised to power minus 4. Percent hydrolysis is equal to 2.4 multiply by 10 raised to power minus 3%. Answer: percent hydrolysis of ammonium acetate equal to 0.55% and sodium acetate equal to 2.4 multiply by 10 raised to power minus 3%. In the above question, given concentration of ammonium acetate is 0.05 molar. Dissociation constant of acid and base is 1.8 multiply by 10 raised to power minus 5. Ammonium acetate is a salt of weak acid and weak base. Upon hydrolysis of ammonium acetate, it gives ammonium hydroxide and acetic acid. At equilibrium, concentration of ammonium ion and acetate ion is C multiplied by 1 minus degree of hydrolysis. Ammonium hydroxide and acetic acid is C multiplied by degree of hydrolysis. KH is equal to Kw divided by Ka and Kb. On putting the equilibrium concentration of ammonium hydroxide and acetic acid and ammonium acetate, KH is equal to square of H divided by 1 minus H. KH is also equal to K west divided by square of Ka. By putting the value of Kw and Ka, KH value comes out to be 0.3086 multiply by 10 raised to power minus 4. Degree of hydrolysis is equal to square root of KH divided by 1 plus square root of KH. By putting the value of KH, degree of hydrolysis is equal to 0.55 multiply by 10 raised to power minus 2. Give ammonium HPH of weak acid and weak base is 7 plus half of pKa minus pKb. In this case pKa is equal to pKb, so pH value comes out to be 7. Part B. Given concentration of aniline acetate is 0.05 molar. Ka is equal to 1.8 multiply by 10 raised to power minus 5. Kb is equal to 4 multiplied by 10 raised to power minus 10, Kh is equal to Kw divided by Ka and Kb. By putting the value of Kw, Ka and Kb, Kh value comes out to be 1.388. Degree of hydrolysis alpha H equal to square root of 1.388 divided by 1 plus square root of 1.388. Degree of hydrolysis is equal to 0.540. pH is equal to 7 plus half of minus log 1.8 plus 5 plus log 4 minus 10. pH value comes out to be 4.67. Part C. Given concentration of ammonium carbonate is 0.05 molar. Ammonium carbonate undergo hydrolysis and hydroxide and carbonic acid. This reaction is a combination of reverse dissociation of ammonium hydroxide and carbonic acid as shown here. 1 divided by Ka2 is much greater than 1 divided by Ka1. Kh value can be found out using the formula Kh equal to Kw divided by Ka2 and Kb. By putting the value of dissociation of water Kw, Ka2 and Kb, we can find out Kh. Given Ka2 of carbonic acid is equal to 4.7 divided by 10 raised to power minus 11. Kb is equal to 1.8 multiplied by 10 raised to power minus 5. On solving, Kh value comes out to be 11.82. Alpha H is equal to square root of Kh divided by 1 plus square root of Kh. By putting the value of Kh, alpha H value comes out be 0.775. pH value is equal to 7 plus half of pKa minus pKb. By putting the value of Ka2 and Kb, pH value of ammonium carbonate is 9.79. Answer Kh equal to 11.82. Degree of hydrolysis equal to 0.775. pH value equal to 9.79. Given concentration of ammonium cyanide is 0.1 molar. Ammonium cyanide undergo hydrolysis and give ammonium hydroxide and hydrogen cyanide. This reaction is a combination of reverse dissociation of ammonium hydroxide and hydrogen cyanide. Kh value can be found out using the formula Kh equal to Kw divided by Ka and Kb. By putting the value of dissociation of water Kw, Ka and Kb, we can find out Kh. Given Ka of hydrogen cyanide is equal to 5.0 divided by 10 raised to power minus 10. Kb is equal to 1.8 multiplied by 10 raised to power minus 5. On solving, Kh value comes out to be 1.11. Alpha H is equal to square root of Kh divided by 1 plus square root of Kh. By putting the value of Kh, alpha H value comes out be 0.513. pH value is equal to 7 plus half of pKa minus pKb. By putting the value of Ka and Kb, pH value of ammonium cyanide is 9.28. Answer Kh equal to 1.11. Degree of hydrolysis equal to 0.513. pH value equal to 9.28. Don't forget, like, share, and subscribe, and we'll see you in the next video. That's right. If you have any questions, whether it's related to the topic of this video or any other academic subject, drop them in the comments, and we will be more than happy to help you out.